video, we are going to discuss about the topic thread. So we should know about, before knowing about the concept of thread, let us know what is a thread. So as we all know that programs are nothing but sequence of instruction, and a process is nothing but a program that is under execution as a process. Each unit of a process is a thread. Okay. So a thread basically is generally referred to as a basic unit of CPU utilization. A unit of a process is referred to as a thread. And in order to uniquely identify a thread, each thread will be associated with a thread identifier, which is referred to as thread ID. And each thread has got their own program counter, register set, and a stack in order to store the temporary data. So when you just look into the diagram for a single threaded process, so you have only a single thread under execution, which will be utilizing the code part, data part, file part, register part, and stack part of the. So these are all the portion in the memory. So in order to store the programming part, you have a section of the memory which is referred to a core. In order to store the data, you have the portion of the memory which is referred to data. And in order to store the files, all the files, because in order to organize the data, they will be stored in files. So those section of the memory is referred to as file section of memory, and registers and stack in order to hold the data during the execution. So as we already studied that whenever an interrupt has to be serviced, the program status word, the content, and the program counter, which holds the address of next instruction, will be stored in the stack portion of the memory before the interrupt is being serviced in order to resume the execution after the interrupt. And coming to the multi-threaded process, so we here they have given 3 threads that are running in parallel in order to improve the throughput. And each thread has got their own stack and the register part, whereas all the 3 threads will be sharing the code section of the memory, data section of the memory, and file section of memory. So the files related to all the threads will be stored in the file portion of the memory. And the programming part related to all the threads will be stored in the code section of the memory, and the data that is being accessible for 3 threads will be stored in the data section of the memory. And in spite of it, each thread have got their own registers and the stack portion. So this is about the single-threaded process and the multi-threaded process. Then moving on to the next part, about example of the threads. For example, when you consider a web server, obviously, as we all know, that web server will need to service more number of multiple users who will be requesting for their service. So traditionally, all the requests to the web server from the clients will be handled one by one. But as a process, in case of multi-process, you have many processes related to one application at a time. And if by the concept of thread, by implementing multi-threading concept, many processes and many threads for a single process can be implemented. So this is about the overview of the thread and example of a thread. And when we want to talk about the types of threads, you have 2 types of threads, namely user thread and kernel thread. As we all know that kernel means they should be supported and managed directly by the operating system. So user thread by the developer or the user, if the thread is being developed and managed, then those threads are referred to as user thread. An example of user threads, POSIX thread, your Mac C thread, Polaris threads, all these are the threads that comes under user threads. Kernel threads, Linux threads, Windows 95, 98, NT 2000, all these are the examples of the threads that are being managed and supported by the operating system. So the thread that is being managed and directly supported with the operating system, those threads are referred to as kernel thread, and they will be operated in the kernel space, and the user thread will be executed in the user space. Then moving on to about the thread libraries. So, the thread libraries will be providing a application programming interface for creating and managing threads. So, whenever, as we all know, that threads are nothing but a process. A unit of a process is a thread. So, in order to create and manage the threads, so there should be a application programming interface. So, which is being provided by the thread library. The thread library provides the user or the developer or the programmer application programming interface in order to develop and manage threads. And as we know about, there are two types of threads. Similarly, thread libraries also falls into two categories. One is your kernel level library, and the other is your user level library. So if user level library means they will be executed in the user space without kernel support. And all the code and data structures for the library will be present in the user space. So here the invoking a function will represent a simple local function called in user space. Whereas if you're implementing a kernel level library, they will be obviously supported directly by the operating system. And in this case, the code and the data structures for the kernel level library exist in the kernel space. Kernel space means the space that is dedicated for the operating system. And here, in case of kernel level library, invoking a function leads to system call to the kernel. So this is about the kernel libraries. You have user level library and kernel level library. Then general strategies for creating multiple threads. So asynchronous threading means, suppose if you have a parent, okay, if a parent and the child execute independently of each other, then you call the threading as asynchronous threading. And synchronous threading, so the parent and the child process will execute concurrently and they will be dependent on one another. So dependent in the sense, so even though the parent has completed its execution, it has to wait for all its children to terminate before it resumes. This is about your synchronous. So in synchronous threading, parent and the children, they are dependent on each other. In asynchronous threading, the parent and the children are independent of each other. Then about the thread library types, there are P threads, Windows threads, and Java threads. P threads, they are referred to as POSIX threads. So they can be provided either as a user level library or kernel level library. Whereas your Windows thread library is referred to as kernel level library, which is available on the Windows system. And Java thread API can be created and directly managed in the Java programs. Moving on to the pthread. So here you have all the header files. In order to create pthread, you should include the header file pthread.h. And here, the thread portion of the the code will be implemented inside the runner method. So they have given void runner, and here the variable is sum. So here the thread is going to calculate the sum of n numbers, and the thread portion, the executable portion of the thread will be placed inside the runner method, which takes the param as the argument. And when main function is being executed, so it takes the command line arguments, which is argc, which is of type integer, and argb, which is of type character array. So here thread identifier is being declared as TID of type pthread underscore t, and the attribute of thread has been declared as attr here. And in order to initiate a thread, set the default attributes of the thread. So init method is being implemented here. And to create a thread, so create method, you have pthread underscore create. Is been that's why you have to include the header file pthread.h, because it's available. This create method, in order to create a thread, we need to call the create function, which takes the parameter thread identifier, the attribute of the thread, the runner method, and the character array. And about the pthread underscore join, it takes the thread ID as well as the second argument of the join will be of null. So what does this join method do? So it just stops the main method or suspend the main method till the runner method gets executed. That is the use of this join method. Uh, since it's present inside the join class, so it has been called using pthread dot join. This method has been present inside pthread class. So pthread uh, dot join. Okay, so this join method will suspend this main method until this runner method is being executed. So inside the runner method, as I told you, you are performing sum of n numbers. So what is this ATOI? So since here the command line arguments is passed as a character array. So here, whatever, suppose if I want to perform sum of 10 numbers. So here that 10 which is being passed as a command line argument will be passed as a string only because it is the argv variable is being declared as a character array. So in order to convert them to your integer, that is array to integer, so this method ATOI is being implemented here. It's being called here. So ATOI param is nothing but the character string that is being passed. So in order to convert the array to the integer, and the variable and the value, integer value will be stored in the upper variable. So using the for loop, the sum of n numbers is being printed. And to exit the thread, you use pthread.exit method. So once sum is being calculated and stored in the sum variable, then the runner method is being implemented till the value of I is equal to upper. And the sum variable will hold the value of sum of the number that is being given as the input. Using printf, the sum of n numbers is being printed here. So this is about creating a pthread. Similar to pthread, we have Windows thread, wherein which you have some modifications. The header file here is to be implemented is windows.h, and the method that has been used, the function that has been implemented as a thread is summation here, and the double word, the upper is given as a double word here, it is returned as a double word. And here, instead of creating thread, so in the previous case in pthread, in order to create a thread, we use pthread underscore create. Here, in case of Windows thread, here create thread. This method is being present inside the class handle. So you create an object to the class handle, that is the thread handle is object. So that is being assigned here. Thread handle is equal to create thread, which takes all the arguments here. The null is nothing but the default security attributes. The default stack size is 0, and you're calling the thread function there. And the parameter of the thread function is passed as a next argument. And the default flag is given as a 0. And you're returning the thread identifier as the last argument in create thread method. So once create method is thread method is called, here within this itself, I'm calling the summation method, which prints the sum of n numbers here. And since I have created thread handle, which is nothing but the object to the class handle, I have to close the handle by calling close handle here. And finally, the sum of n numbers is being printed. This is using Windows thread. Then moving on to the Java thread. So thread creation in Java here involves creating a thread object and passing it as an instance of a class that implements runnable, followed by invoking the start of method on the thread object. So here, obviously in Java program, so whenever thread has to be implemented in Java program, so we have to call the run method. This run method will be available. The declaration of this public void run method is available inside the interface runnable. So the class, you have to implement the runnable methods in the class where you're going to implement the thread task. Here, the class name is given as task here, implements runnable. As I told you, runnable is the interface which has got the method declaration of public void run. So you're going to implement the interface in order to access the public void runoff. I'm going to implement the interface runnable, and here I'm going to just give the code for the run method for the thread. So system.out.println, I am a thread. So in order to execute this run method, I need to call start method by creating object to the thread class. So here thread object name is worker is equal to new thread and a new thread of new the class name. So here the object is nothing but the instance of a class task which is used to call the start method. So once when start method is being called, automatically this will invoke the run method, and inside the run method I'll be having the code for executing my thread. So this is about implementing the Java thread. So in this section, we studied about what is a thread and how the single-threaded process and multi-threaded process will be sharing the memory portion, and about the example of thread, about the types of thread, and about the thread libraries, your general strategies for creating multiple threads and different types of threads, about the P thread, your Windows thread and Java thread. Thread library types also we have studied in this video lecture. Thank you.